Okay, reactions of metals. We're told that calcium reacts with water to make calcium hydroxide and hydrogen gas. And we have to describe what would be seen when a piece of calcium is dropped into a container of water. 2 marks. Okay. Well, the hydrogen is a gas. Okay? So the first thing you can say is you would see bubbles. Okay, or effervescence. Okay? What else for our second mark? Well, this calcium is reacting to form calcium hydroxide. So the lump of calcium will get smaller and disappear. So you can say that the calcium gets smaller or disappears. Okay? Don't say that it dissolves. It's not dissolving. I know it looks like it's dissolving. If you put salt in water, the salt disappears as well, but that's because the salt is dissolving. Dissolving is not... It's not a chemical reaction, okay? When you put salt in water, salt is sodium chloride. The sodium remains as sodium and the chloride remains as chloride. I mean, yes, they separate from each other and go their separate ways, but there's no chemical reaction, okay? Here, there's a chemical reaction. If the calcium were to dissolve, it would remain as just calcium, but it isn't. It's reacting and forming calcium hydroxide, so it's not dissolving, okay? So say that it gets smaller or that it disappears, okay? Right, what else? Well, as it effervesces and gets smaller, it moves around on or in the water. I think on the water. So say it moves around. Okay, and we can actually say a fourth thing. We've already got our 2 marks, okay? You could stop there if you wanted, but always try and say more just to be sure. They give you a bit of a clue. Here, they point out that the calcium hydroxide is actually a solid, okay? Calcium is a solid, starts off as a solid. That's a liquid, of course, water. But yes, calcium hydroxide is a solid, which means that it would form a precipitate, okay? So you would see a precipitate. So you would see, remember the question is asking what you would see. So you precipitate. You could also say that the water goes cloudy, okay? You know the lime water test? If you didn't know it, you need to learn it. The lime water test is a test for the presence of carbon dioxide gas. You bubble the carbon dioxide gas through lime water, and if carbon dioxide is there, it turns cloudy. And the reason it turns cloudy is because of the appearance of calcium hydroxide in the water. So there's a link there. See, you're learning stuff. Okay, good. So definitely got 2 marks there. Right. Write the balanced equation for the reaction between magnesium and steam. Okay, steam is just water in gaseous form. So it's just H2O, right? So they tell you that when magnesium reacts with water, it forms magnesium oxide and hydrogen. So that's nice of them. So, what is it again? Magnesium plus water. Okay, like I say, they tell you it forms magnesium oxide and hydrogen. So we've just got to balance it. 1 magnesium there, 1 magnesium there. It's good. 2 hydrogens there, 2 hydrogens there. It's good. 1 oxygen there, 1 oxygen there. We don't need to do anything. Fine. What was that? 2 marks? I'll take that. Right. Electronic configurations. So we're told that, where shall I do this? I'll try and squeeze it in here. So we're told that the electronic configuration of magnesium is 282, okay, and calcium is 282. Okay. When magnesium and calcium react with water, they form positive ions. Suggests an explanation in terms of their electronic configurations why calcium is more reactive than magnesium. Okay, standard exam question. This one with the 2882 is more reactive than this one with the 282. Why? Okay. I think this is a 2-mark question, but I'll just say everything you need to know. Right. The outer electrons in calcium are further away from the nucleus, okay? So just commit this to memory and regurgitate it in the exam. So for calcium, the outer electrons are further away from the nucleus. From nucleus. All right? Standard exam technique. Say something, therefore something, therefore something, lay it out in logical order. Try to avoid using the word because that sort of goes backwards. Try and use the word therefore, right? So, therefore, I'm just going to write it shorthand, okay? Therefore, the outer electrons experience more shielding. Okay? Examiners love catchphrases and key words. Get the word shielding in this question. Okay? Right, what's next? Therefore, less attraction between the outer electrons and the nucleus. Okay? Therefore, easier to remove. The outer electrons are easy to remove because there's less attraction between them and the nucleus. Okay, so we've definitely got our 2 marks. Just learn that, regurgitate it in the exam for these sort of questions. It always comes up. Why is this electron, why are these less reactive, more reactive than these? The because therefore thing, I'll just quickly say something about that. Like I say, it's better to say this, therefore this, therefore this, therefore this, because you can keep writing and it forms a nice logical chain, and the word therefore doesn't break it up. But if you say because, for example, if you start with the conclusion that the outer electrons are easier to remove because there's less attraction between the outer electrons and the nucleus, that statement in itself is correct. But why is there less attraction between the outer electrons and the nucleus? You then have to say, and that is because the outer electrons experience more shielding, which is because it's not as nice. See, you're going backwards. It's better to use therefore and go forwards. Okay, right. What's next? Right. So we're told that calcium bromide contains 0.2 grams of calcium and this sample 0.8 grams of bromine, and we have to calculate the empirical formula. The empirical formula, that's the one with just the simplest ratios, okay? not the molecular formula, but you have to find just the ratio in molar terms. With the given mass, we have to calculate the molar terms, the relative number of moles of calcium and bromine. Okay. They tell us that the relative atomic masses are calcium is 40. Now write down the units here, very important, grams per mole. Technically, the relative atomic mass of calcium is just 40, but that means that calcium weighs 40 grams per mole, okay? So technically AR, relative atomic mass, doesn't have units, but there's such little difference here that I'm going to slightly cheat and write that. It's fine for you to write that, okay? I want you to write the units. We're going to use the units to solve this question. Knowing the units, I'm going to say that the units of AR is grams per mole, okay? That's fine. Just learn that if calcium has an AR of 40, it means it weighs 40 grams per mole. Write units down. You have to use the units to solve this question the easy way, the way I like doing it, which is the best way. Okay? It'll make it easy for you. So learn the units, it's grams per mole, and bromine is 80 grams per mole. Again, technically, shouldn't really write equals there, doesn't matter. Right. Okay, so why am I obsessed with units? Because it makes it easy. Look, let's do calcium first, okay? So, calcium. They've given us 0.2 grams, right? And we know that calcium weighs 40 grams per mole. So what are we going to do? Just by looking at the units, we know that if we divide something that's in terms of grams by something that's in terms or units of grams per mole, okay? Write the units in and look, the grams cancel. Grams on the top, grams on the bottom. And when you divide and divide again, the moles flips up to the top. So that becomes, it's just 0.2 over 40 moles. We know that by examining the units, if we divide, it tells you that you have to divide. That's how I know how to divide. That we end up with something in units of moles, which is what we want. We want the molar ratio to get the empirical formula. Okay? And even if you don't know that you need moles for the empirical formula, they've given you something in terms of grams and something in terms of grams per mole. It's a pretty good bet that you're going to have to divide that one by that to get something in terms of moles, right? If you're given 2, work out the third. Even if you don't really know what you're doing, just work out the third, you'll get a mark. Okay. And 0.2 divided by 40 is 0.005 moles. Okay, so we know the number of moles of calcium. Do the same with the bromine. Okay, so we've got 0.8 grams divided by 80 grams per mole. Grams on the top, grams on the bottom. Moles flips up to the top, which is 0.8 over 80 moles, which is 0.010 moles. Okay, so we've got the number of moles of calcium, number of moles of bromine. So, to finish off, the calcium to bromine ratio is 0.005 to 0.010, which is 2 to 1, or 1 to 2. Okay, great. So therefore the empirical formula is 1 calcium and 2 bromines, or calcium, or bromides, calcium bromide. you don't write the 1. It's invisible if you like. It's just calcium Br2. And that is how it's done. Look at the units.